Productive, paying attention here, taking notes, all that jazz. Notice the title is special. Is anybody special in here? Are you special, Franco? Moreno, are you Franco? Are you special? Tecas, are you special?
Yeah.
Are you special, Soto?
Everyone's special.
Are you sure? You want to know if you're special? Okay. Ramirez, you special? Notice the word special is in our title. There's actually, check this out. There's right triangles that are not special, and there's right triangles, thanks for cutting me off. There's right triangles that are special versus ones that are not. There's only two that are special. I'm about to draw them on the board. You're going to draw them with me. The first right triangle that's special, ready, watch this, is what we call a 45, 45, 90 right triangle. I'm going to draw that. That's the first special one. First write this down and I'll answer. How about that? Deal? No, you did it. You're still writing. No, I'm not special. It's a normal Joe Blow.
Why?
That's a different philosophical question. We'll get into that after this. Okay? Now, there's always something special about a 45, 45, 90. The legs are always congruent. Go to put a little hash mark there. The legs are always the same size. In other words, we're dealing with an isosceles right triangle when this angle is 45 degrees and this angle is 45 degrees. Always. It's always the case. Notice, see how it's special. It doesn't even stop there. If you call now, just kidding. No, he got it. Extra stands for he's the one that got the joke. Look how special it is now. Watch this. Look how special this is. The hypotenuse, going to write HYP, is always, gentlemen, here we go. It's always, without fail, equal to the square root of 2 times the leg. Always. There's this special relationship always occurring. That's that. Always. Behold how special it is. So far, so good. There's one more special triangle. All the other right triangles are not special. There's only one more, though. Unlike humans, like Soto said, everyone's special, except Ugia.
No, you're special. You chose to say no.
Let's move on. We'll continue. Here's the other one now. The other special right triangle is ready. Here we go. I'm going to draw a right triangle where one leg is longer than the other. And one angle is 90 degrees. Obviously, it has to be 90 degrees or else it wouldn't be a right triangle. But one of the angles is 60 degrees, and the other one's 30 degrees. We call this a 30, 60, 90 right triangle. This is another special one. Are the legs the same size on this one? Are the legs the same size? No, the legs are different size. We have a longer leg and we have a shorter leg. Right, Moreno? Going to write long leg. Look at, there's a long leg, and here's a short leg. And obviously, this is a hypotenuse. Obviously, you already know that. But on a 30, 60, 90, you got a long leg, you got a short leg. The short leg, I like to abbreviate. I just say schleg. Long leg and the schleg. Or short leg. You'll see why that's important right now when I give you why it's so special. Watch this. So for the 45, 45, 90, only one relationship is special. But for a 30, 60, 90, Two relationships are special. Ready? Put your seatbelt on. It's going to knock you out right here. Watch this. Hypotenuse is always equal to the short leg, I'll call it the schleg, times 2. Always. No matter how big or small, if you have a 30, 60, 90, this is always going to be true. The hypotenuse is 2 times the schleg. Or the schleg times 2. However you want to write it. Right, Moreno? But it doesn't stop there, Moreno. It's even more special. There's a second relationship. Wait, there's more. The long leg, I'm going to put L leg. The long leg is equal to radical 3 times the schleg.
That doesn't make sense to me.
It's crazy.
It's radical 3
Times the schleg.
What does that mean? You know when you have like equals when the answer to the question is like maybe x equals 3 radical 3?
So that means it's an irrational number that they simplified, huh?
No, but like it's like that's like that. I don't know, like what does it mean?
It means that it's whatever the square root of 3 is, only God knows because it's an infinite decimal. Whatever that number is, multiply it by that, and that's what x is. So we're obligated, and we're inescapably bound to actually approximate. We have no other choice. In other words, if I'm a construction worker and you say, can you chop me a piece of board that's 2 rad 3 inches long? I have to calculate rad 3 and then round it to the nearest tenth, 100,000, however exactly you want. I'm going to have to approximate because that decimal is infinite. So to answer, that's a long way of answering your question of saying, Dave, only God knows what exactly square root of 3 is. What we can do is we can get more and more exact by however detailed you want to approximate it to. You want to approximate to the hundredth, tens, thousands, millions, billions, it's up to you. Now back over here. So out of all the right triangles on Earth, watch this. Out of all the right triangles on planet Earth, or any right triangle you can fathom, I'm going to fathom them right now, don't write this down. Let's say this is 49 degrees and let's see, this is 41 degrees. Look at this right triangle. This is called a 41, 49, 90 right triangle. It's a right triangle, but it ain't a 45, 45, 90. And it ain't a 30, 60, 90, so this is not special. Because it's not a 45, 45, 90. Now, all the angles, no doubt, they add up to be 180. But it's not a special right triangle. Now, let me show you the power of this. Let me show you the power of this now. Example 1. Yeah, we should take notes right now. I'll take you right after, I promise. Example 1, ready? Go ahead and copy this example. We're only going to do one example right now. We'll do some more later. Actually, we'll do two. We'll do 2 examples. Go ahead and copy example 1 down. Hold on. Go ahead and copy example 1 down. Go ahead and draw yourself a right triangle. Go ahead and draw yourself a 30, 60, 90 right triangle, Burns. We got a 30, 60, 90 right triangle here. Yes, it's special because there's only two of them, the 45, 45, 90 and a 30, 60, 90. So, our mission is to solve for x and y, the sides, x and y. Okay, solve for x and y. It's a right triangle, so I'm going to go ahead and use Pythagorean theorem. A squared plus b squared equals c squared. What are my legs?
60 and x.
Wait, legs, not angles. I'm talking about sides here, huh?
1 and x.
1 and x. So look at this. 1 squared plus x squared. What's my hypotenuse, Soto?
Y.
Y squared. Do you guys like see a problem here? What's going on? Let's see. Let's keep going. See, what's 1 to the second power? 1. So look at 1 plus x squared equals y squared. What's the problem here? I got two variables. I got two unknowns. I got x unknown and y unknown. So Pythagorean theorem is not going to help us. You see that? There's two unknowns. I could only use Pythagorean theorem if I have 2 out of the 3 sides. If I only have 1 out of 3 sides, wave goodbye to Pythagoras. He's out of here. He's not going to help us. Everybody wave bye. Everybody. But even though they wave goodbye, or we wave goodbye to Pythagoras, have no fear, because who's here? The 30, 60, 90 theorem is here. Right here, set on. Phone's away, so I give you that stamp. I'm going to use these two truths, these two theorems, these two laws about a 30, 60, 90, and guess what? This is going to save the day. We don't need Pythagoras anymore if we have a special right triangle. Watch. Watch the magic. Let me write the first relationship. The hypotenuse is the Schleg times 2. Write it with me. I'm going to write HYP equals 2 times the Schleg. I'm going to put the 2 in front instead of the 2 after the Schleg. So 2 times the Schleg. It does. Hypotenuse equals 2 times the Schleg. What's the Schleg here? What's the shorter leg? X or 1? 1. Let me replace Schleg with 1. Look at this. Hypotenuse equals 2 times 1. What's the hypotenuse?
2.
What's the hypotenuse here? Y. So look at it. Let me replace what? Hypotenuse with what? Y is 2. We figured, look at it. We solved for Y. Look at this. Y is 2. The hypotenuse ended up being 2. That was like so easy, it was kind of scary. Seriously. We just solved for Y in like 2 steps. And we didn't even use Pythagoras. Are we done? Did we solve for X and Y? We only solved for Y, huh?
Yeah, you only solved for Y.
We got to solve for X now. What side is X? Is X a long leg, short leg, or the hypotenuse?
Long leg.
It's long leg. So I'm going to use this. Look at. I'm going to use this relationship now. The second one. Look at. Long leg equals rad 3 times the Schleg. Watch this.
So the Schleg is 2.
Let's see. Let's see what the Schleg is.
1.
Let me write out my relationship. Look at long leg. I put L leg. Long leg equals rad 3 times the Schleg.
Which is 4.
Let's see. What is a long leg here? X. I'll replace long leg with X. Equals rad 3. What's the Schleg? Schleg is 1. X equals rad 3. You want the exact or approximate? Well, that's up to you. That's the exact answer. X equals rad 3. Done. I could approximate if I want to near stance. Just type in rad 3 in my calculator, round off.
Will it ever be a whole number?
No.
360 will never be a whole number.
The long leg will never be. You see why though, huh? Logically? Because you'll have to multiply by rad 3, which is always irrational.
I know the rational.
Some violin music. Wait up, one more. Again, that was scary. We solved for x and y. Look how easy it was in green and blue without using Pythagoras. All we were given was one side, 1, and we had to solve for the other 2 sides. Without Pythagoras, we did it. Is that scary or what? What I know? Yeah. Last one. Franco's trembling. Watch this. Watch this, watch this.
We're
gonna do this one?
So right now, I'm marking names off in my mind, so at the end of the day, I'm going to pass you over. I'm not going to give you a stamp because you weren't taking notes. Just a little FYI. Let's take turns talking. You're lying. You're lying. Write it down and I'll give you an extra stamp. Let's see. If you get it, I'll give you an extra stamp. Write it down right now and circle it. Burns, is this a special right triangle?
No.
No? Set on, is this a special right triangle?
Yes.
Why? You're right. Why? Simple argument. Why is it special? Ramirez, why is it special? Exactly. It's got 30, 60, and 90 degrees inside. There's only 2 special right triangles, Burns. There's only 2. The rest are not special. The only 2 special right triangles are the 45, 45, 90, 30, 60, 90. Let's rock and roll. Here we go.
They will all look the same. Are they special?
I think I just said that.
Oh, is the numbers that's inside?
Yeah, the degrees inside.
Oh.
Right.
It's
It's all right. It's fine. Here we go. We're only given one side. We're given the long leg. We're given the long leg. Burns, check this out. We're not given the hypotenuse, y, and we're not given the schleg, x. But since this is a very special right triangle, we're going to be able to solve for both. Watch the magic. First relationship that I know is a hypotenuse equals 2 times the schleg. It does sound German. Schleg. It's like a Nazi word or something.
How would it be that?
It's a Nazi death camp word.
What if I hurt my shoulder?
German's I rather learn German. That's one of the
German is some of the greatest philosophers came out of Germany, greatest mathematicians, scientists. So what should I replace with the hypotenuse here?
1.
Nice. The hypotenuse is opposite 90 degrees, so y, watch this, y is twice the schleg is x. So that's not going to help us, because we have 2 unknowns. After this one, so I got you. I'm almost done. Relax. Watch this. I'm going to use a second relationship, Soto. The long leg equals rad 3 times the schleg. Again, L leg. Forgive my chicken scratch cursive here.
Why don't you teach that like a college?
We'll get to that later. I'll take that as a compliment.
Say,
If you start taking notes.
I'm taking those all the time.
If I go right now, I bet you this is not written down.
That's what it is.
I swear to God, though. Let's see it. Is that correct?
That's another stamp. That's a stamp.
All right, here we go. So this one didn't work because that resulted in 2 unknowns. So forget that. Long leg, though, is given. Long leg is 4 rad 3. Watch this. 4 rad 3 equals rad 3 times the Schlag. What's the Schlag up here? Thank you. That was kind of scary, but okay. Let's get x by itself. Look at it, Soto. How do I get x by itself here?
Divide. Rad 3.
Just get rid of the rad 3 by dividing by rad 3. Watch this, you guys. Check this out. Check this out. By to that, bring down the equals. X equals, watch this, 4 rad 3 divided by rad 3. But the numerator, denominator, that's the same. I can cancel out. That becomes 1. They're gone. So x equals 4. Almost done. We got to solve for y now.
Can I get it in 2 cents for doing it in my head? That's just.
Oh, wait, let's see. So he said x is 4 and y is 8. Let's see if he's right. Hold up. Let's solve for y now. We're going to use the other relationship now. Y equals 2 times the Schlag. We already know what the Schlag is. We just figured out what the Schlag was. The Schlag is 4. So y equals 2 times 4. So that means y is equal to 8. Ioannovich did it again. He got the extra stamp. So y is equal to 8, x equal 4, and we did it without Pythagorean
Why
theorem.
you just look at it and notice it like that?
Watch the language though.
Well, you learn it. That's why. You couldn't tell that, see? I can't, that's why. You learned it. He learned it.
Any
I
questions?
learned it. I can do it.
Apart from the brilliance and genius of Ioannovich, any questions on this last example? Yes, Soto? Get out of here. I'm going to put the game on. If there's no questions, continue with your assignments. Yes.